So the rate of cooling experiments related to alternative to practical. Question number 4 from classified paper 6. Students are investigating how the use of a lid or an insulation affects the rate of the cooling of hot water in a beaker. They use apparatus shown in figure 2.1. So you can see the apparatus is there. Beaker A is with insulation, where beaker B is with a lid without insulation, and a thermometer is clamped. Record the room temperature. So what is the room temperature here? You can use the screen.
23.
Yeah. So it is 23. That's right. So you can use your mic, you can use the screen annotation, or you can also use a chat, what is convenient to answer. So 23 degree. So we write 23 degree. Then 100 cm cube of a hot water is poured into a beaker A. So student pour 100 cm cube of a hot water into this beaker, and then he record the temperature of the hot water. So 10, 30 seconds, 60 seconds, 90 seconds, 120 seconds. So you have to complete the question is the process for beaker B is also done. So complete the heading, the column heading basically, and the time column. So you can use the screen annotation to complete the column heading. Column heading means the units. What is the unit of a time?
Second.
So unit of the time is used second. So we will write second here. And unit of a temperature, that is degree Celsius. So we'll. So why it's of 2 mark? 1 mark is for completing this column heading, like writing a unit. And then with 30-second interval, it is done. So 0, 30, 60, 90, 120, 150, and 180. So you just have to use the values here and write it down. The next one, write a conclusion stating whether the insulation or a lid is more effective reducing a rate of cooling. And justify your answer with reference to, so the first one, the first reading was with insulation, and the second reading was with lid. So how to identify whether like rate of cooling is affected? What you can do, like in 180 seconds, how much is a temperature change or a temperature difference with insulation?
Subtract.
Subtract. So what's the answer for this? The temperature difference. First one is 83 and 68.5. So 83 minus 68.5.
14.5.
So it will be 14.5. So the one with the insulation, it was having a temperature change of 14.5. And with the lid, what is the temperature change? 86 and 78.5. So when you take a difference,
7.5.
so 7.5 is the difference. So which one is more effective, lid or insulation, to reduce the rate of heat loss?
Lid.
Lid, because with the lid, temperature change was small. With insulation, there was a greater temperature change. So they asked justify with reference to the reading. So how we justify with reference to reading? We'll mention that in 180 seconds, the temperature change with insulation was 14.5, where the temperature change with the lid is only 7.5. So lid is better in reducing the rate of heat loss as compared to that of insulation. So here, write a conclusion stating whether the insulation or a lid is more effective reducing the rate of a cooling. So we'll mention lid, and why? Because with the lid, the temperature change was only 7.5, but with insulation, it was 14.5. Is it clear, Parchi?
Yes.
Yes, sir, clear.
Then one student think that the experiment does not show how effective insulation is on its own or how effective lids is on its own. Like this experiment, we are not sure whether only insulation is a factor here or whether lid is a factor. So it suggests an additional experiment which could be used to show the effective, like how effective a lid or insulation is, and explain how additional result could be used. So right now we are comparing, like one is there with an insulation, another one is there with a lid, but this is not like a fair judgment or a fair comparison. How we can make a fair comparison or compare that, whether a insulation is affecting the rate of a cooling or lid is affecting the rate of cooling? So what we should do, that is the question.
Again?
The question is, like, we did this experiment, one is there with an insulation and another one is there with a lid. If we want to compare them, like which one is more effective, so what we should do?
Sir, can we
Higher
add fan
temperature
to
of water.
increase the rate of cooling, like to see which one will have less temperature decrease?
Yeah, or we can also look, if you check the temperature, the beaker with insulation was at 83 and a beaker with a lid was 86. So means they don't have the same temperature, initial temperatures. So what we should do, we should repeat the experiment with same initial temperature, and there should be one more experiment, that there should be another beaker without insulation and without lid. And there should
Sir,
be
you're
a,
lagging, sir.
sorry?
You're lagging.
Okay, okay. Is it fine now?
Yes, sir.
Yes.
Look, the thing is that this experiment is not a fair right now. Why it is not a fair? First thing, the temperature, initial temperature should be same. The second thing, that when we are doing this experiment, so we should do one without insulation and without lid as well. So we have a better comparison, because like we will check if there was no insulation and no lid, what is the rate of cooling? Then we'll check with insulation, what is the rate of cooling? And there should be another experiment with both insulation and lid together. So there should be insulation and there should be a lid as well. So we will have like fair comparison. Fair comparison, like we can compare whether insulation is affecting the rate of cooling, whether lid is affecting the rate of cooling, or whether both of them affecting the rate of cooling, or none of them affecting the rate of cooling. So what we should have another beaker without insulation and without lid, and we have one more beaker with insulation and with the lid put together. So we have a better comparison. Like we can compare this with this one, because this one, like we can compare B with D, as there is lid but no insulation. And we can also compare this with this one, that this is without insulation and this is with insulation. So we'll have a fair comparison between them. Is it clear?
Yes.
So what we should do, we should repeat the experiment. So how the additional result could be used? So only one you can mention. So we should repeat the experiment. Additional apparatus, just a beaker is needed. Additional experiment. So we'll repeat the experiment with the without insulation and lid, and we will compare the temperature change. Like we will find whether how the rate of a cooling affected by lid and, or without lid and insulation. So there should be one more experiment in which we will not have a lid, we will not have an insulation, we will compare that. Or you can also mention, do another experiment with lid and with insulation, with like both of them to compare, have a fair comparison. Is it clear, the last question?
Yes, sir.
The next one is calculate XA, the average cooling rate of a beaker A in 180 seconds and then last 80 seconds. And how to calculate the average rate? Like the temperature change in 180 second divided by total time, time will be 180. And then 180 from from 180 till the last, because where T is 180. And this is a starting temperature, this is a temperature at 180. We work out the rate of cooling. So for beaker A, if we want to work out the rate of cooling, so this was 30, 60, 90, 120, 150, and 180. So how we work out the rate of a cooling? We work out the temperature change. So temperature change was 83 minus 68.5, which was 14.5, divided by time. How much time is there? It is 180. So 14.5 divided by 180. What's the answer for this?
0.08.
0.08. So the rate of a cooling will be 0.08. Any other digit is there after it?
0.080555.
So 0.081 we can say. And the unit will be degree centigrade. Unit will be degree centigrade per second. So this was 0.081 degree centigrade per second. Then students in another school are carrying out this experiment using identical equipment. Like students are using this experiment, same equipment is used. State why they should make the initial temperature of a water same as in this experiment if they are to obtain average rate of a cooling as same as table 2.1. Assume that the room temperature is same in each case. Use the result from a beaker A. Use the result. So use the result from beaker A to explain why this factor should be controlled. So you can see, yeah, the thing is that if it is having a higher initial temperature, rate of a cooling is faster. If you see here this part, like first 30 second, how much the temperature change was there? It was 83 becomes 79. So what is the temperature change in first 30 second?
4.
So 4. But when you check the last 30 second, like this was 150 and 180, what is the temperature change? Only 1. So what it shows that if the liquid is having a higher temperature, it will cool down faster. If a liquid is having a lower temperature, it will take longer time to cool down. So rate of the heat loss or rate of a cooling depends on the temperature of a liquid. Like if a liquid is hot or a high temperature, it will have a faster or a greater rate of a cooling as compared to a liquid at low temperature. So what we'll mention here, the points that a student in another school carry out experiment, use the result from beaker A, explain why this factor should be controlled. So statement you will mention rate of a cooling is affected by temperature of a liquid. And how you write the result, like how you conclude this, that it is affected by temperature. You'll mention in first 30 seconds, the temperature change was 4. But in the last 30 seconds, the temperature change was only 1. So higher temperature, greater the rate of cooling. Like if your liquid is at high temperature, it will cool down much faster. Is it clear? The question 4 part E2.
Yes, sir.
Yes, you can also say higher temperature, higher rate of a cooling. That is, but look, in the question, usually they ask to use the value from the table. So if they ask use the value from the table, you have to quote the value. You have to mention the value. If you just mention higher temperature, higher rate of a cooling, but you did not quote the value, then you will likely to lose a mark for that. Like 1 mark. As I mentioned here, use a result from beaker A. So we have to use a result from beaker A, so we have to quote some values. Can we write higher temperature part? Yes, you can mention that. Higher temperature, higher rate of a cooling, or rate of a cooling is proportional to temperature. That you can mention. That is how to write a statement is not an issue, but the explanation, you should always use the correct statement with, like you should justify the statement with reference to the results. One more question, again related to rate of a cooling. Students are investigating the cooling of a hot water in a beaker. You will find the rate of a cooling experiments are the most common one. Means it's like every year there is a question from this one. From balancing, sometime there's a question from balancing, sometime question from extension. Like if there's a normally a balancing question, then extension question is not there. Same thing if it's a time period question, you don't find a density question. But rate of cooling is the most common one you will find almost every year. They ask a question, sometime planning experiment, sometime you have to state the results. Students are investigating a cooling of a hot water in a beaker. They are using an apparatus shown in figure 2.1. A thermometer is clamped and a beaker is there. What is the initial temperature, room temperature? So room temperature is 21. So you can use screen annotation to. So 21. The next one, a volume of 150 cm cube of a hot water is poured into a beaker. A similar pattern is there. Like we put a hot water, then we record the initial temperature and we record the temperature for like about 3 minutes or 4 minutes with a 30-second interval. Usually it's like this. Then complete the column heading or the heading. So whenever a table is there, table or even a graph is there, it should be with a column heading. So second and degree centigrade. Describe one precaution that you would take to ensure the temperature reading are accurate as possible. Look, whenever you're doing an experiment related to rate of cooling and you want to make sure that your temperature readings are reliable, accurate as possible, number one, you should avoid a parallax error or look perpendicular. Then you should wait until the readings stop rising or changing. And you should steer before recording the reading because it should have a uniform transfer of heat energy throughout, and keep the thermometer should not touch the base or the wall of thermometer should not touch the base or the wall of the beaker. So these are the precautions you should always take whenever you are measuring a temperature by using a thermometer. Number one, you should avoid a parallax error. If you write look perpendicular, avoid parallax error, that is fine. The thermometer should not touch the base or the wall. And you should stir before recording the temperature. And one more thing, you should wait for the temperature until the temperature stop rising. We don't have to mention insulation because the insulation may change the experiment, because rate of cooling can be factored by insulation, it can be affected by lid. So if you mention you should insulate the beaker, so that is not the right one, because maybe the experiment was, we are just investigating how a rate of a cooling is affected by uninsulated beaker. So don't mention anything related to insulation. If they ask how you can minimize the heat loss, then you will mention that use insulation. So one precaution, as I mentioned, 4 of them, you can write any one out of 4. Look perpendicular, should not touch the base or wall, stir before taking readings, and wait for temperature stop rising. Any one you can write out of 4. Then calculate the average rate of a cooling for first 90 second and then for next 90 second. Like, so how to calculate a rate of a cooling for first 90 second? For first 90 second, what is the temperature change? It starts with 95 and ending at 79. What's the temperature change? 95 minus 79, which is
16.
16, and divided by the temperature, divided by the time interval, because we are finding the rate. So 16 divided by 90. What is the rate of cooling?
0.17.
0.17.
After 17, what number is there?
7.
7.
So it should be 0.18, I can also say. 0.177, or I can say 0.18. And the unit, 1 mark is for always unit. So unit of rate of cooling is degree centigrade or Celsius per second. For next 90 seconds, 79 and 68. How much is the temperature change here? 79 becomes 68.5. What's the temperature change?
So,
10.4.
10.4.
So 10.5 is the temperature change. So 10.5 divided by 90. What's the answer for rate of cooling?
0.11666.
0.11.
0.12.
0.12 you can also say. So you can clearly see that the rate of the cooling, yeah, 0.116 or 0.12 is okay, fine. 2 significant or 3 significant figure answers are fine. So you can see the first 90 second, the rate of a cooling was 0.18. But the next 90 second, the rate of a cooling is 0.12. It means the rate of a cooling always decreases. In the beginning, it is maximum and then it reduces. So this answer we'll write here 0.18. And this answer we'll write as 0.12. If you write your answer in 3 significant figure, like you write 0.177, that is fine. If you write 0.11, what was the number? 6, I guess.
Yes.
Yeah, so you both are correct. But one more, like always, write the unit for rate of cooling. Then the third one is the rate of a cooling from 180 to 270 seconds. So the third one, the same way we will find a rate of a cooling from 180 to 270. So the temperature change, it was 68 becomes 62.
6 degrees.
6 degrees, and then divided by time interval, which is 96 divided by 90. What's the rate of cooling?
0.0666.
0.066 or 0.1 if you say, that is also fine. So different rate of coolings, as you can see in the beginning, it is maximum. So the temperature of a water falls at time passes. Use the result from C, like the result from C, the rate of a cooling. Describe the pattern of a rate of a cooling during this experiment. So what happened to the rate of a cooling? So we'll mention the rate of a cooling decreases. And how we justify? We can justify with the value of x1, yeah, decreases by time. That is
So,
right. How
small
we
mark.
can, yeah, rate of cooling decreases, but we have to, the question is justify the answer by reference to the result. So you have to use your result. If you just mention rate of a cooling is decreasing, that is not the full answer. So and you have to justify, like, 1 mark is for mentioning rate of a cooling is decreasing and then reference to the result. Like in the beginning, initially the rate of the cooling when we work out, it was 0.18. Then the second value was it was 0.02, 0.112. And the third one we work out 0.07. So you can clearly see that the rate of a cooling is decreasing. Then the last one, give an estimate probable final temperature of a water if it left for many hours. This is a very common question. Even they ask in chemistry, like what predict the temperature of a mixture after 5 hours, 10 hours, or 24 hours. So what will the temperature? The temperature of the mixture, if even it's a hot or a cold, the temperature of a mixture, it will come in thermal equilibrium with the surrounding. So it will always be same as the surrounding temperature. So what was the surrounding temperature? Like the room temperature in the beginning of experiment we did, it was 21. So if the room temperature was 21 and if we have a hot water and we leave it for many hours, so what will be the temperature of that hot water? Like now it won't be hot, it will be same as the room temperature. So it will be 21. Is it clear?
So room temperature is 21.
Yeah, room temperature is 21. So this temperature should also be 21. Because like with after several hours, it will lose energy and it will come in thermal equilibrium with the surrounding. So thermal equilibrium means like rate of heat loss and gain will be same, so its temperature won't change much. A student in another school carry out a similar experiment. She started with the hot water at a lower initial temperature. Suggest how her cooling rate are likely to compare with those we calculated in C1. Like this student did the experiment. She started at 95, but another student in another lab, she carried out an experiment and she got like she maybe started with 85, a lower initial temperature. When we compare her result, the new student result with the previous one, what will happen to the new results? It about a rate of a cooling. She will have a higher rate of a cooling and or a lower rate of cooling.
Lower.
So she will have a lower rate of a cooling or a rate of a cooling will be small less. And reason is that because rate
The
of a
lower the
cooling,
temperature,
yeah, rate of a cooling depends on the temperature of a liquid. Higher temperature, greater rate of a cooling. So suggest how her cooling rates are likely to compare. So the suggestion, the rate of a cooling will be and explanation here, the rate of a cooling depends on initial temperature. And even you can also mention it also depends on temperature difference of the liquid and surrounding. As the rate of a cooling depends on temperature difference between the liquid and the surrounding or room. State one variable other than the initial temperature which student should control. Like what is another variable which student should keep constant for this to have a fair results? If the other student is doing the same experiment, room temperature, yeah, room temperature or what else? Amount of a liquid she is using, yeah, volume of the water. So you can mention volume of a water, you can mention the room temperature, should be same, or only one you have to write or the volume of the water. So this was question 5.